Okay, welcome back. We're going to go ahead and take a look and see how this goal-based pathfinding works. In this video, we're going to create a number field and start a vector field. And so just to remind us what's going on here, if I have a bunch of blocks set up, these are all cells that are occupied. And at some point, the peasants are going to start coming out. And when they do, they're going to be able to follow the path, no matter how I build this, all the way back to the yellow dot. And so that's the point of this pathfinding exercise. We want these guys to be able to, during the run of the game, change where they're going. And so I can put my dragons out here and they'll be shooting. But if I open this up and, oops, I can't do that because that would close off the whole map. But if I open this up and close this guy, all of these guys are going to run back around the other way. So they know how to do this, how to get from one end to the other, and we're going to create a number field to get started in that process. So currently this is where we are. We have a grid of cell objects. Each cell object has a ID number, and so we start up here loading these guys with cell 1 all the way through 15 and then come back up here and so forth. And so in the last video we found that for each given cell we can find neighbors. This guy would, for instance, just have one neighbor since he's in the lower right hand corner and one of his neighbors is occupied. The only neighbor in his neighbors array is going to be this one cell. This guy, whoever number 237, will have 4 cells, 236, 252, 238, and 224, and we're going to assign these neighbors numbers. Starting with this guy down here, we're going to set him equal to 0. So in order to do that, let me go ahead and make one change in the code, and I'm going to, first of all, I set the value at 5,000, and I think I'm going to change that. So instead of ID, I'm going to go ahead and say this dot value, and when I do that and save it, I'll come back and take a look and see what this looks like, and it turns out I'm going to see they all have the value 5,000. I want to start this guy off at 0. You know, in fact, I think what we'll do is we'll change that 5,000 to -1. So every cell starts off with a value -1, and then we change the goal to 0. So let me go ahead and see if that looks good. So every cell now has an ID and a value, and we're going to start by changing the values, and we're going to start by changing the first value equal to 0. So back in the code, I'm going to go over to, let's see, in my load grid, I think what I'll do down here is I'll just create a variable called this.goal, and this.goal is going to be equal to this.grid, and I want to go to the last 2 elements. And so the last 2 elements, or the last element rather, is going to have coordinates this dot num columns and -1. And I'll do the same thing for the next guy, except he's going to be this dot rows, or num rows rather. So num rows -1. And so that's my goal. And when I do this, the first thing I want to do is to ensure that this guy is not going to be occupied. So I'll say this dot goal, let's see, dot occupied, and I'm going to set that equal to false. So he's not going to, no matter if he gets loaded with, I'm setting all of these guys equal to false, but if through this guy here he gets a true value, I'll ensure that guy is false, and I'm going to set his value, so this dot value, or this dot goal dot value is going to be equal to 0. So that's going to be my starting point. So now if I run this, I should see the similar map, except I should see in the goal down here, and I did a typo, or probably a typo. Let's see. Cannot set property game. Let's see. This dot load grid. It says occupied of undefined. So that means my guy is not defined. But if I look back in my source code, this dot goal occupied, it doesn't know what that is. So let's put a breakpoint right here and see what's going on. I'm going to go ahead and load this guy, swing this guy out a little bit, and let's see. This dot grid is good, this dot columns is good, and this dot rows is spelled incorrectly. So let's go back and change that, and I'll say this dot rows, so coming back down here into load grid, and this dot rows, let's see, right down here, I've got 2 S's. Save that. Let's try it again. And now if I run it, I still have an error. No, I don't. Oh, I've got a breakpoint. Let's change that. There it goes. Okay, so notice this guy is now 0, and I have -1, -1. Everything's -1. So now I want to go ahead and grab my neighbors of this first cell and I'm going to add 1 to this value. So 0 plus 1 is 1. So these two guys should be equal to 1. But let's see how to do that. First, I'll go back over here to my game class, and I am going to come down here to Brushfire. The two basic parts of Brushfire are called load number field and load vector field. The reason I call this Brushfire is I've heard that nickname for goal-based pathfinding. I've heard it called Brushfire or bushfire, but the idea is that it is, or grassfire rather, it's like setting a fire at the goal, and it's going to burn back around through any obstacles, and if there's a path back to the starting point, it will supply the appropriate number field according to wherever that starting point happens to be. Okay, so the basic approach here is I'm going to come into this first part, and I'm going to create a variable. I'm going to set the start to the first and goal to last. And so check cells. I'm going to create an array called check cells, and I'm putting this dot goal. So that, remember, that's a cell object. And basically inside this check cells array are the cells that I still need to check. And so the first thing I'm going to do when I come in is I'll create a little while loop here, and I'm going to say while this check cells has length. So I could say just simply check cells dot length, as long as that length is greater than 0, that will work. However, if check cells length is 0, it'll work just the same way as if I put it like this: 0 evaluates to false. And then what I'm going to do is I will take check cells and I'll create a variable in here called current. So I'll say var current, I'll just say cur for short, is equal to, and I'm going to take check cells and I'm going to take out the first cell. In this case, there's only one cell in there. And so let me spell this correctly, check cells. So I'm taking this guy and I'm going to use a function called shift. So we've used push before. Push just pushes an element into the end of an array. So if I said check cells push, I'd push a cell in there, but shift pops the first element out of the front and removes it. So I'm going to go ahead and shift the goal. Or I'm just going to say shift. And so when I first come in here, since the goal is the only value in here, this guy is going to pull out, current is going to be pointing to goal the first time through, and this guy will be temporarily empty. And then what I want to do is I want to push in all of current's neighbors. And so to do that, I'll create a little for loop, and remember that any cell can have between 1 and 4 neighbors. I guess the lower right hand corner can have is 1, but let's go ahead, or 2. Let's say var I is equal to, and we'll do 0, and we're going to look through the neighbors. So neighbors is a one-dimensional array. It's a property of the cell class, and so as long as I is less than cur.neighbors dot length, then I'll continue to do this, and I'll simply say I++. And so coming in here now, I'm going to push these guys in. I need to have a dot here and a dot here, and I need to spell length correctly. Okay, in any case, so what I'm going to do now is go ahead and push each of the neighbors in here. I want to say I have another little typo here. So I don't want to push every cell, actually. What I want to do is just push in those cells which still have a value of -1. So I'm going to say if current neighbors I value equals -1, then I want to push it into check cells, because if it has a value other than -1, 0 for instance, then it has already been changed. I only want to push the guys with value -1 into my current neighbors, and so then I say current neighbors value. I take each of the values that have a value of -1, I'm going to add current.value plus 1 to those guys. Now if I come back over to, let's see, I'm going to come up maybe here, and I'll go ahead and say Brushfire. So this dot Brushfire, and that should do it. And now I'm calling that guy. As soon as I load the grid, then I'll call Brushfire. Let's see if this works. I'll come back over here now, and I have an error. Let's see what's going on. I don't have an, oh, I still have a breakpoint. Let's get rid of that guy and see if this runs. And there it goes. So this guy gets 1. Notice this crawls out here to 2 and then 3. This guy's going up 2, 3, 4, and so this calls all the way back to 31. And so if I'm at this cell, I know that I want to go to the cell that has the lowest value, so that's 30, then 29. I've got two values of 28 here, so it can go either way, but that's the number field, and that is the start of the Brushfire technique. The next thing is we want to be able to create a vector that goes from the center of this guy to the center of this guy, and I'm going to use that to steer my enemies. And so all the enemies will be starting off here. We'll start them off as like little balls, and they're going to find their way through here. The other thing I want to add is that when I click on a cell, I would like that cell to change from being unoccupied to occupied, or vice versa. Okay, so to create the vector field, I guess the first thing I need to do is figure out which of my neighbors. Each of my neighbors now, for each cell, it knows which neighbors it has. Since each cell has a value assigned according to the number field, we can find out which of my neighbors has the smallest value. And so to do that, I'm going to traverse the entire guy again, and the entire grid again rather, and I'll go through the columns and the rows. And so for each cell in the grid, I want to find the neighbor with the smallest value. So I'll say if not this grid occupied, then I want to go ahead and write a function called get smallest neighbor value. So right after I do load neighbors, I'll come in right after that guy over in my cell class, and I will write a function called get smallest neighbor values. And so I'll just take inside a cell object at this point, or inside the cell class. So each cell is going to be responsible for not only looking through each of the neighbors and ultimately assigning them values, but finally we're going to find out which one is the smallest. And so I'll just traverse the neighbors again with a for loop, and I will figure out which one has the smallest value. So let me just pop the code in here so you guys don't have to watch me type all this in. I'll just explain what's going on. I'm setting a variable smallest equal to a large number, larger than the largest number in my number field, and then I'll traverse the neighbors array, so I equals 0 to I equals neighbors.length, they're less than neighbors.length, I plus plus, and I'm saying if this guy value is the value of this cell is less than smallest, it then becomes the smallest. So it should be, the first one should become the smallest, but then every time I come through this loop, I'll look through each one, and I will have the value of the smallest value in my neighbors array. And so then I'm going to set, I'm going to create a property called smallest neighbor index, and that's just going to be equal to I. Then I can have a pointer to my smallest neighbor, and I can say this neighbor, and I've got that smallest neighbor index in the neighbors array, so I know which of my neighbors has the smallest index, and I'm using that to create this guy. And so back up in the top on my properties, I have got smallest neighbor index, starts off at 0, but I'll go ahead and appoint it to the correct one, and this guy is going to be my smallest neighbor. This is the neighbor that I want to point to, and so I will create a vector from this cell to the neighbor with the smallest value. And that's how I'm going to steer things through this little maze. No matter how I set up the obstacles, this should do it. Let me go ahead and save this. And in the next bit, we are going to figure out how to create those vectors. Remember, we're going to create for the enemies a location vector, a velocity vector, and an acceleration vector. And we're going to use the vector in each cell for kind of a direction to move the enemy in the proper direction. Okay, so I've come back up into Run, and notice that in Run I'm rendering the towers, I'm rendering all these different things, and I'm rendering the grid. And so I took it up earlier, I took out render enemies. We had created this in one of our earlier videos where we were talking about vectors and acceleration. So now what I have is, if I run this, I have the grid and I have my enemies just running as they were before. And so let me grab this guy back in so we can see the whole game. So if I come back to this guy and I get rid of rendering the grid, right? So I get this guy. So the grid, we're actually not going to show the grid in the final game, but let's go ahead and render this without the grid. So I just have these enemies moving around, and if I go ahead and plug this guy back in, I can see the enemies. Notice I'm rendering the enemies after I render the grid. That's kind of important if I want to see the enemies. So I'm going to go ahead and put the grid down, and then the enemies will be bouncing around. And what I want to do now is have the enemies start up here in this upper left-hand corner, and I want them to follow that number field. We're going to create vectors going from a particular cell to its neighbor with the smallest value, and then I just have to steer these things through all these obstacles until they get down here. Okay, I'm going to try to put this next chunk in pretty quickly, and so I can see load enemies. Currently what I'm doing is I'm going through my enemies array, which is a one-dimensional array, or actually I'm just taking in the number of enemies. Right now the array is empty. And then I'm taking a location where I'm just taking, I go to the middle of the canvas in terms of both width and height, and I'm spawning my enemies there. Or I'm getting a location vector so that when I create a new enemy, that's where it will spawn. And then I push it into enemies. So when I'm done with this, whatever number of enemies comes in here as a parameter, I will create an array of that many enemies. I'm going to change this. I'm going to change this significantly. And so what I'll do now is I have put in a function inside of load enemies. And so first of all, I'm going to go, just like before, I'm going to have the same number of enemies, or whatever number of enemies I push in. I'm going to create a for loop, but I'm going to have to look for a free cell. I was originally going to just do a stage where I spawned just in the upper left-hand corner, but what I'm going to do now is I'm just going to look for a free cell. And so I'm going to take the X location and a Y location. I'm going to say this.grid freecell.column, freecell.row, freecell.column, freecell.row. So this is going to have a column number and row number for a free cell. And this method is going to find that free cell. So I'm going to send in this, which is the game. I'm going to call this method, which we'll look at in just a minute. And then it's going to return an object that's going to have a column and row number of a cell that's not occupied. And so I'm going to create some random spawning points, but I just have to make sure that where I'm spawning isn't already occupied. So that's what's going on here. This cell, or this method, is actually inside this same function. So that's a big difference between JavaScript and Java, is that in Java you never write methods inside of methods. But here I have load enemies, and I'm calling a method inside of that, and this function is inside of load enemies. And so it's going to take in a reference to the game object, because when I come inside this function, the value of this changes. So now I have game is equal to this input parameter, and I'm creating an object called cell index, and it's just going to have two values. It's going to have, remember, an object is just a name value pair. So C and R, I set those equal both to 0 initially, and then I'm going to go ahead and take a random value. So we've done this kind of thing before. I'm going to take the number of columns divided by 4, so all of my enemies are going to spawn on the left 25% vertically, and then anywhere in any number of the rows. And so I'll get a column value and a row value, and I'll say if that guy is occupied, or while that guy is occupied, do that again. And I keep doing this until I come up with a grid value at column row that is not occupied. As soon as I find one that's not occupied, I'll come down here and notice that I have my object that I made, cell index. It has a C and an R property, so those guys get loaded in here, and then I'm going to return cell index, and cell index is going to be loaded up into this variable called free cell. So now I can take freecell.c, since this object up here is called free cell. It has a C and an R value, a column and a row value for a cell that is not occupied. And so from that, I'm going to create a spawn location, which is just a vector. I take my X loc and Y loc, and it creates a spawn location. So now when I create a new enemy, it's going to spawn in any part, any row, and in the left 25% of the screen. And so now what I want to do is come back and figure out how to steer in the direction towards the neighbor with the smallest value. Now I'm going to go into my enemies class, and we're going to change the acceleration. What we're going to do is steer using acceleration as we did before, but now acceleration is going to be the vector that is going to be from where I am currently located, where the enemy is currently located, and it's going to be pointing towards the center of the cell, the neighbor cell, with the smallest value. And so first of all, I'm going to come in here and just set this guy equal to 0, 0, and all of this is going to be happening here in update. And then I'm going to come down here. I'm currently adding acceleration to velocity. Of course, when I set acceleration up here at 0, 0, so that will have no effect. And then I'm taking velocity and adding it to location. So they are moving around. But in between these two, I'm going to calculate acceleration. And the way I'm going to calculate it is I'm going to take the difference between the vector, the location of my enemy, that's the location vector in my enemy class, and the location of the cell. And more specifically, I came in here in the cell and I created another vector in addition to location. The location vector right now is telling me where to place the cell, and its point of reference is the upper left-hand corner. And so I think it'll be a little bit easier if I make this change where I create another vector called center. And now I'm just going to take the location X and Y, and I'm just going to take the game, and I'm going to do half the cell width. So cell width is a property in the tower game, and so I've taken in game, a reference to the tower game here, and I'm setting that game, this dot game is equal to game. And so game dot cell width divided by 2, that's going to put me halfway in terms of the horizontal position, and in terms of the vertical position, this is going to point to the center of the cell. And so that's where I want to steer towards. So back in the enemy class, I'm going to steer towards that. And so coming back down here, update, again, I apologize for being such a painfully slow typist. I'm going to paste in the code and just explain what's going on. I'm going to, after I check edges, I want to get the column and row, the cell that I'm in, and to do that, we've done this kind of thing before. I just take the location. So I'm inside the enemy class right now. So this is the location of the enemy. And so each enemy knows its own location, and I'll just take the tower game, which remember is a global variable, and I'm going to take the cell width. So that will give me the column number and the row number. Once I have a column number and a row number, then I can say if that guy equals the goal, just return. So when my enemy gets all the way down to the end and it is inside the goal, I'm just going to not do anything after that. But right here it says tower game grid. If this thing exists and this thing is not occupied, then I want my current cell to be this cell. So this thing exists. I want to check that. And then if that exists, I'm going to just give a shorthand reference to that called current cell. And then my next cell is going to be that current cell dot smallest number. Remember, we have a property in each cell, which is a reference to this next cell I want to go to the neighbor with the smallest value. So I'm going to call that next cell. And then I'm going to do the same thing we did before, where I'm going to say this dot acceleration sub get new is going to take in two vectors. When I subtract, when I take the difference of these two vectors, it's going to create a third vector. That's what sub get new means. I'm not going to change acceleration immediately, but then I'm going to take that value. It's going to return that. And I'm just, in this case, call that acceleration. And then I'm going to set the magnitude of that to 0.5. So now I've got a little tiny vector that's going to change my velocity little bit by little bit, but it's going to be pointing it each time towards the center of the next cell. And so I take that guy and add it to velocity. I'm going to limit velocity to 2. And I don't remember if I showed you how to make this particular method. Maybe if we have time, we'll take a look at that. And then I take acceleration, add it to velocity, and that actually, it would be better if this were down here. I take acceleration, add it to velocity, and then I take I limit it to 2. I don't let the velocity go over 2. And then I take velocity and add it to location. So let's go ahead and save that. And that's really about it. Let's go ahead and see this run. Okay, I'm going to go ahead and hit reload. And there it goes. These guys are moving along. No matter how these guys get set up, no matter how the obstacles are set up, these guys are going to find their way around the obstacles. They're just going to the next cell. Acceleration is pushing them to the center of the next cell. And then they get all down there to the bottom, to the grid with the value 0. So I'm going to go ahead and stop this here, and we'll pick that up in the next video. Bye-bye.